just realized I turned off my mic, and so, okay, I am back. I tell you what, folks, it was my oldest son there telling me I forgot to turn on the audio. So, I tell you, one day I'll get this routine down. So, I'm George McBroom. Thanks for joining me. Here we're going to take a look at some galaxies in the constellation Canes Venetici tonight. And I'm going to make this much quicker on this galaxy since apparently we've been here for a little bit. So I apologize for that. This is, as I said, we're going to look at these galaxies in Canes Venetici. Canes Venetici is two stars, Corcoroli and Chara, which are a straight line, and they're kind of off the back side of the handle of the Big Dipper. The constellation starts coming up in spring, and it's kind of a spring, summertime constellation, so it's going to be up during the kind of prime viewing hours during your spring and summertime. It is fairly rich in galaxies. There's quite a few. There's probably 10 to 15 or possibly more. Some of them are very faint and very small, but we're going to take a look at 6 of those that we can see kind of the best. So what we have here in front of us is Messier 51 or M51. The M or the Messier is the name of the catalog, and it's named after a man named Charles Messier. He was an astronomer back in the 1700s, I believe, and he cataloged some of the first objects, or was kind of one of the first people to catalog some of these faint objects. So this one's M51, it's the 51st in the catalog, and it is called the Whirlpool Galaxy. It is actually a named galaxy. It's named the Whirlpool Galaxy because of its shape, because it's kind of a perfect little whirlpool. It's what we call a grand design spiral galaxy, and it sits about 28 million light years away from Earth. So the light you're seeing right now has been traveling towards us for 28 million years. So you are basically time traveling. You're looking back in time. This is what that galaxy looked like 28 million years ago. So if we wanted to see what it looks like in 28 million years, we'd have to wait another 28 million years. It's about 38,000 light years across, and it's a really interesting galaxy. And what you can see here is that there are two objects, right? I mean, it's a grand design spiral, so you expect just to have these perfect arms, but you've got this glob at one end. Well, this glob is in fact another galaxy. At some point, these galaxies came into contact with one another and have ended up interacting with one another gravitationally. So perhaps they ran into one another, passed through each other, or maybe they just came close enough for their gravity to lock onto one another. And they have interacted, and one or the other has lost mass. I would assume that our little small fella here has probably lost some mass to M51. We'll point out some features here. If you can see my pointer, I think you can. Here in the center, you've got this really bright area. This is the core of the galaxy, so this is the center. It's very hot. There's a lot of hot gas, hot ionized gas and dust. You've got stars forming in here. It's a very violent area. There's possibly a black hole in here. And then as you move out, of course, it turns into your standard galaxy areas, right, where you'd have solar system, or you might have other solar systems, other planets, and you can see some of these dark strips or dark stripes on some of these areas. Those are dust lanes, and they're basically exactly what you'd expect. They're very just cold areas of dust that are just kind of trapped in the gravity of this galaxy. Very, very beautiful galaxy. A lot of great detail that you can pull out of it. Not all the ones we see tonight are going to have that much detail, but I'll try to do what I can without keeping the exposures too long, because I basically can let these expose for a long period of time and have it stack to try to bring some of those details out. But some of them are just faint, and it would take way too long to really collect the full amount of light that we would need. So in the interest of keeping that going and making up for lost time, we are going to go ahead and move on to our next target. So I will see you there. folks. I know this is kind of a back and forth. It's a little messy here. I don't know what's going on with my audio and some of my equipment tonight. It's really misbehaving. I'll have to buy a better mic, I think. All right, so before I lost the audio there, I was trying to fix the problem, lost the audio again. So we're going back in. Sorry if it's a little messy sounding, if there's some weird kind of buzzing and feedback there. There's not a whole lot I can do about that. I don't know what's going on. So as I was saying, so what we're on now is M63 or Messier 63. This is also called the Sunflower Galaxy, and it is, if you can see in a more high-resolution image, or an image that's got more light collected, which we could sit here and let this accumulate a lot more light and gather more detail, but I've already got it running on 50-second exposures, so I don't really want to run too long on these exposures. So if you see more, but you can see here that there's a large portion that outlies this. This is also a spiral galaxy, okay? So the reason it's called the sunflower, because it's really bright here, kind of in the center is really bright, and then you've got this wide, this wide kind of dimmer, kind of mottled area outside of it. Kind of gives it a sunflower kind of appearance, I suppose. But what's interesting is it's actually got many arms. It's not like the M51 where you could really follow out 2 arms. There are multiple arms, and you can have galaxies that have 8 arms, 10 arms. They can have many arms, and so this is one of those. You just can't see the detail, but you can see that there's kind of a speckled, kind of a mottled appearance, and that's because of all those tightly wound, kind of tightly packed arms. So M63 is about 29 million light years away, so it's about the same distance away as M51. But it is about 101,000 light years across. So it's very wide, it's very large. And what happens sometimes with these larger galaxies is that they tend to have their luminosity, if you will, the amount of light that they're pushing out, tends to be spread over a much larger area, so they can be much dimmer than you would think. You go, hey, it's a large galaxy, it should be really bright, but that's not always the case. Sometimes that light is spread over such a large area that they actually become dimmer than one that is a little bit smaller. So you can see that here. M51 was very defined, very bright, very easy to see, and it was about a third of the size. And so, so in Sunflower Galaxy, it's pretty, and if you can really, I encourage you to look these up. Go online, look at these. Most of these have got Hubble Space Telescope images, and let's be honest, you really can't beat looking at the Hubble images of these things. So please explore further when we get done tonight. With that, I'm going to move on to our next target, and so I will see you over there. We've got this again set on about 50-second exposure, so it's going to take it a minute here to accumulate some light. So we're going to see here what we come out with detail-wise. M94 is another one of those fairly faint. It's not particularly large. It's actually about the same size as M51, and it's slightly closer than M51, but there are no rules when it comes to galaxies as far as how they're gonna show how bright they're gonna be. So they play by their own rules, I guess. So we will see what we can see detail-wise, and we're going to. What I'm going to try to do, I'll cut that core down because the core on M94 is actually very bright, and so what happens is it actually, of course, drowns out what's going on. It can actually drown out kind of what's going on, so we're going to cut that inner core area. It cuts a little too much, so we'll just bring it back up and we'll look at it as it is. It'll clear up a little bit once we get a couple of exposures stacked, but it's not going to get a whole lot clearer than that, again, because it's just of the morphology of the galaxy. So this is M94, Messier 94, and again, this is another spiral galaxy, and it is about 16 million light years away. So, like I said, it is a little bit closer than M51, which is 28 million light years away, but it is about the same size. It's only 30,000 light years across, and a little interesting little tidbit. So most galaxies are moving kind of towards or away from one another. Things are moving in the universe. They're not just sitting there hovering and just hanging still. Things are in motion. They're gliding through the universe at extreme speeds, and this one is no exception. This one is actually moving away from us at 210 miles per second. So figure on your 210 miles is slightly shy of Savannah, if you've ever been to Savannah from Atlanta, or where I live anyways, near Atlanta, and it's getting there in a second would be pretty nice. It's about a 6-hour drive, so so figure on that's really moving right through the universe. So the other things that we'll talk about here kind of real briefly with this one is, again, it's a spiral galaxy. I don't want to say seen one, seen them all. They're all very interesting in their own unique ways, and this one does have its own kind of unique features. So this one is actually kind of known for its very bright core, which you can tell here. Even when I tried to cut down the highlights on here, the white levels on here, it was still very, very bright, kind of almost bloated, right? Because it's just a very bright core, sending out a lot of light, and it tends to have this little halo of very bright, hot area around it. But then it just abruptly changes to a very, very cool outer region in the galaxy, right? And that's kind of a hallmark of this particular galaxy. It's just some of its features. So again, it's they're all really unique, really neat in their own way. So let's see here. We are going to move on, I think, to our next target. Again, this one's not, it's not rich in features that we can pull out right here. I'd have to do some really long exposures, collect a lot of light. So, one thing that we do when we use telescopes, and especially when we're using imaging type equipment, is that we are gathering light, right? We're collecting it, and it's being funneled into our device, and the longer we stare at that particular object, the more photons of light that are collected by our camera, and thus more opportunity for detail. So we've got what we've got here, and like I said, I don't want to sit here for 2-minute exposures with you. Not that I don't want to spend the time with you, but I don't think you want to spend let's go ahead and move on to our next object, and I will see you there. So, wow, okay, we got a really wide screen, so I should probably fix that. Get our exposure. Now, I'm going to tell you, I love this one. I find this one just really neat. It's really interesting, and you won't see many like this, which I think to me is what makes it so fun and kind of unique. We'll let our images stack. So when I say stack, and I'm going to tell you while it's kind of doing this before I tell you about the Galaxy itself. So my software that runs my camera, there's a multitude of softwares that'll run these cameras. They all do phenomenal things, and this one is really no exception. It's a nice, easy, intuitive piece of software. It's real user-friendly. Obviously, it lets me broadcast, has built-in broadcast capabilities. The reason it wasn't working earlier when I tried to go live is there's actually a glitch, I think, in one of the versions that runs on my newer laptop, so I had to switch to my older laptop, which, how often do you switch to something older to make it work better? So this software, though, has this really neat capability of being able to live stack images. So what it is doing is every time it creates an exposure, it is internally matching the stars that it sees in the image with the stars in the previous image, and aligning those images and putting them on top of one another. And the concept behind that is that it eliminates the noise in the image. It helps to eliminate some of that noise by knocking out lighter spots with darker spots on the next exposure. That and I could go into. There's so many things I could go into about noise. I'm by no means an expert, but of course, with that, it also is going to lay detail that maybe wasn't picked up in a different image with detail that's collected in a new image, and it kind of overlaps them and adds them together, so that you end up with a detail with far more imagery than you would with not without the stacking. So as of right now, this image right here has got a total of 150 seconds of light accumulation stacked into it. So the more it stacks, nominally it'll get a little bit better. Again, always would be better to have each of those stacks have more accumulation on their own, and then you would get more detail. So with that, I am going to knock down the brightness there just a smidge, knock our dark levels down a little bit, black levels there, bring up our midtones just a smidge, and just trying to get this thing so it's kind of as much detail as we can get. Alright, so like I said, this here is an irregular galaxy. So this is NGC 4449. So NGC stands for New General Catalog. It's just another catalog of objects. Some of the, actually, I think all of the Messier objects have an NGC, corresponding NGC number. They've kind of been incorporated into that, and then of course then there's a whole other slew of other objects within that NGC catalog, and there are multiple catalogs that have been created. You'd think that they'd get together and create one single catalog, but that'd be crazy talk. So what we have is an irregular, and it's actually a dwarf galaxy, so it's actually quite small, and it's irregular. It has no pattern. There's no spiral to it. It's not what could be called an elliptical galaxy. It is a completely irregular galaxy. Everything in it is tied together gravitationally, just like you would expect in a galaxy. There is a core. There is an area inside that is star forming, that is hot, and in outer reaches where older stars are at, and other stars that have moved further out. But it just doesn't have any kind of a pattern to it. It is 12 million light years away, so 12 million light years from Earth. Not as exciting as 28 or 29 million light years, but hey, it's 12 million light years, so 12 million year old light is pretty cool, I suppose. And it's only about 20,000 light years across, so it's not drastically smaller than our whirlpool or our spiral galaxy when you look at it or our M94 when you look at it in general numbers. But I mean, you've got to figure that's around 18, well, anywhere from 10 to almost 20 light years difference in size. So that's quite a bit smaller. One of the things that we see, so like I said, this has a central area that contains large population of very young stars. So you can tell internally here it's much brighter in here, and it's because it's like the core, right? So there's a lot of hot ionized gas and very young populations of stars, and in fact scientists, astronomers have come around to estimate that most of the stars in there in that inner reach area are only about 5 million years old. So extremely infant stars, right? Because our sun is several billion years old. This is only about 5 million. So these stars formed, well after the majority of the larger dinosaur population was gone. We were in mammals and large mammal territory by the point that these stars started to form. So that's pretty impressive when you think on it in those terms. And it's just a neat galaxy. Like I said, you can see out here you've got some blue and red areas, which are going to be some of your, some slightly older stars. The red especially are cooler stars, older stars. And then of course some of it's just gas. It's just ionized gases that are being heated by the stars around them. So again, another beautiful galaxy. Definitely interesting with some very interesting features. So with that, we are going to move on to our next galaxy. I will see you there. target here. Of course, right now it's just a dark screen because we're waiting on our first actual shot here. So what we are looking at now is going to be NGC 5033. So it is a spiral galaxy, much like the several others that we've seen already tonight, which again, I'll be honest with you, are very interesting. There are different types. As I said, there are what are called elliptical galaxies, and let's be quite frank, elliptical galaxies are kind of boring. They really are. They're flat, kind of misty-looking disks with a really kind of bright yellow core. Because they're old galaxies, they've burned up a lot of their gas and material. Most of their stars, a lot of their stars have already died out. They're kind of boring, honestly, to an extent. Spiral galaxies really are kind of much more fun. They tend to be a little bit younger morphology of stars, of galaxies, so you tend to see a little bit more interesting stuff with those. Let's see here. With that, let's see here what we can say about 5033. So 5033 is about 37 million light years away and about 137,000 light years across. So it is a large galaxy. It's actually rather large, and it is going to be difficult here. I may try to knock up our time just a little bit on accumulation. We're going to go for 70 seconds here on some of our accumulation and see if that's going to help provide a little more detail, because I'd really like you to be able to see some of the detail on this. It's actually not a very dim galaxy. It's a fairly decent sized galaxy. Let's see here. I'm trying to see. It does have some warping, as it says here. I was kind of looking to see if I could find you a little extra detail. Significant warping is visible in the southern half of the disk. And it's a sprawling spiral galaxy with thick arms. There's several pink star-forming H2 regions, it says, that are in there. Those are not something that we're going to see the detail of in our image, so we're going to try to let this thing gather a little bit more light here and see if we can pull out just a smidge more detail on it. But I will see what I can do, fiddling with some of these settings, and hopefully drag at least some of the interesting kind of shape out of this thing. If anyone can still see what's going on here.